What's good, everyone? In this video, we're going to do another kind of theoretical or kind of introductory video. I realize I've talked about a lot of frameworks and tools, but not really kind of introduced what those ecosystems are beforehand to people that might be kind of new to this space. So that's the idea behind this type of video. And today specifically, right, is a kind of company or tool that we've used quite extensively in my videos already, but I wanted to introduce for anyone that might be new in this ecosystem or starting this playlist essentially. And the kind of specific entity that we're talking about here is HuggingFace. And HuggingFace is a company that kind of specializes in machine learning systems and also kind of democratizing ML is their whole meaning. And we'll kind of dive into what that exactly means today and what is available within this ecosystem. So depending on your ML problem or your ML use case, maybe you can kind of see or derive the value in terms of what Hugging Face can provide. And in my opinion, this is kind of a tool or something that all ML and LLM engineers, both in 2025 and beyond, really need to be familiar or comfortable with due to kind of its purpose and also how useful and extensive it is going to be in a lot of these ML engineering tasks, even if you have your own custom use cases. So before we can even get into what it is, we'll talk about what is open source machine learning. We talked about open source in the traditional software engineering worlds, but when I speak about it in the ML space, what does open source or open weight necessarily mean? And then we'll introduce what Hugging Face is, and then what are the different things that exist within this ecosystem. So if you've seen some of my videos before, you'll know that we've kind of hit some of these terms before, used some of these packages before, but we'll kind of take an overarching look at the entire Hugging Face ecosystem itself too, and see what's available. And this is not like all encompassing, so there's definitely more to it, but this will cover some of the main points that I've at least seen that are useful for myself personally in my ML projects. And then we'll also talk about how Hugging Face integrates with the cloud, where the value is, and why those two in conjunction, right, can really help you build production grade ML applications and Gen AI applications, both for traditional and large language models, honestly. So the first point we did want to talk about, right, is open source slash weight for ML. And this might be my terminology. I've never been the best with terms. I know there's formal ways of describing things such as packages or APIs. So don't take me in terms of the rigid terms as the most serious, but at least my understanding in terms of open source and open weight models, right? As we know, all ML models get trained, and then there's updated model weights to kind of reflect your trained model architecture that you're essentially working with, right? So with machine learning models, what we're going to take a look at here is open source ML models means that the way these models have been trained is exposed as long as these model weights. So hey, this is how I was able to achieve my final trained model. This is the kind of training data script I used, and here are the exposed model weights. Then there's also open model kind of weights as well, where maybe the training is not exposed, but you can see the final kind of exposed weights, which reflect the model architecture as kind of publicly available for you. So with both open source models and weights, right, you kind of have some insight into how this model was built slash trained and what it was trained on. And that's where the idea of open source machine learning kind of really originates from. And this is different, right? So if you think about the opposite, which are kind of closed models, or at least some of the popular ones, if we think about the Claude models and some of the GPT models, there's a few within OpenAI that are now open sourced or open weighted. I don't remember exactly. These are closed models. They're exposed via APIs, but we don't really have a full understanding or visibility into what exactly is the kind of way this was trained, what it was trained on, and what are the final model weights looking like. So companies, right, or model providers kind of make a strategic decision on what models they want to expose, what ones they want to keep gated, depending on their use cases. Now, Hugging Face, right, where it comes in is for the open kind of ML ecosystem in terms of model weights and also even model training if that's exposed as well. So you can think of Hugging Face almost as a GitHub for ML models, where we're essentially exposing these different model weights that you can interact with, and you have full visibility and kind of transparency into basically these different models that you might be interacting with. So there needed to be a singular kind of platform where these open models could be exposed and interacted with, and that's where Hugging Face really comes, and that's where you hear the term democratize kind of ML, where you're really putting ML in the hands of every developer because you can see and access these open models. And you also have the transparency angle in terms of understanding how was it trained. This is what my model architecture, my model weights look like. So you can think of Hugging Face as kind of the platform at its premise that exposes these different models, right? And when I say exposes these different models, obviously you can think of each of these models. We'll see in the UI as well in a second as kind of having their own model cards with their model information and the weights. But it also exposes them via APIs slash packages that it's built that will help you interface with these open models. Now, the super popular one that, once again, like I said, I think every ML or LLM engineer should know is transformers. With transformers, basically, you can point towards the specific model. Let's say, for example, BERT base, and let's say that's the Hugging Face model ID. Every model basically has an ID or delimiter that kind of specifies which model we're working with, along with whatever provider, let's say like Google. I don't know if it was Google that released BERT, but essentially, with every Hugging Face model, we have this ID which exposes it and its weights essentially. And via the Transformers Python API, basically, or package here, you can pull down these model weights and then you can conduct things such as training, horrible handwriting, I know, training and inference with them. So as a developer, you now have this freedom through transformers to kind of interact with these models. And obviously there's different operations that are also supported through training and inference. We've talked about things such as the trainer class before. We've talked about the pipeline object, which is a higher level object that does both tokenization and inference. Essentially what transformers does is it exposes ways that you can interface with these models and common machine learning model operations that you can conduct with these models as well. And along with transformers, there's a bunch of other libraries that's also exposed that help with these common kind of ML operations that we're talking about. And some of these include data sets, where it exposes kind of curated data sets for different tasks. So you might have something, for example, for Q&A. You might have something for summarization. There's a lot of public data sets that exposes. So for a lot of my kind of machine learning POCs that I've built, I use some of these native Hugging Face data sets that exist that they've curated. And then for evaluation, they have kind of built-in data science metrics across different tasks. So for summarization, for example, there might be some built-in tasks that kind of exist there. Then there's also things like PEFT. This is kind of for LLM adapter-based training that we've talked about before. But essentially the main theme here, right? And we've also talked of trainer. That's another popular construct within transformers, actually. Some of these are standalone libraries. Some of these are constructs within transformers. We'll dive into kind of each of these, and you'll see them in our examples as well. But essentially what's being exposed here, right, is that these are different ML operations that we can, for example, kind of work with. And what what Hugging Face has done is, via these packages and libraries, it's simplified a lot of the data science knowledge or kind of heavy lifting you have to do in other angles, where it lets you focus on the actual ML engineering portion of things. So with data sets, I don't really need to focus on curating a data set, kind of scraping, or things of that sort for my POC. I can use the datasets package to simply grab something for my own task. I can use Evaluate for some of the built-in algorithms for some common operations that I might see out there. Rather than implementing PEFT or those kind of QLoRa-based techniques myself, I have those exposed already with this higher level library that I can be interfacing with. Via Trainer, I abstract out a lot of the different PyTorch code that I might have to traditionally do to kind of train my ML models and interface directly with transformers. So all of these neatly fit with that transformers package for you to build kind of sophisticated ML applications and perform operations that might traditionally take long. So a lot of the heavy lift is taken care of for you via these different packages that are provided in the Transformers ecosystem or the Hugging Face ecosystem. So not only is it a model provider, but it provides different packages, or sorry, not model provider, it's a model platform for all these different providers to share their models. It also provides all these different packages that help simplify and abstract out previously kind of complicated ML operations, essentially. There's still a learning curve where you have to learn how to use this, just like any other Python library or API, obviously, but it makes it easy and it lets you stay within the same ecosystem. So while we have standalone Python packages that help with ML operations such as training and inference, you also need cloud integration. Because at the end of the day, you need the hardware and kind of that managed ecosystem or self-managed ecosystem for you to flesh out these ML applications, right? And what Hugging Face does is it provides deep learning containers that directly integrate with different kind of cloud providers. So this includes SageMaker, this includes Azure, I honestly don't know about GCP in terms of their level of integration there. I'd assume there's some, but it depends on kind of model or the different service that you might be working with. But what they do is they provide these containers for training and inference, which come with the runtime environment configured for these transformers models and provide that execution environment. So, for example, there's text generation inference, which is a model serving engine, right? That Hugging Face has released. And for those that want to use it in conjunction with the hardware and managed hosting environment that something like SageMaker might provide on AWS, there's these managed deep learning containers that are provided essentially as kind of a collab between the cloud provider and Hugging Face that let you easily port over that transformers code that you might be interfacing with onto the cloud provider. So you can think of kind of as the compute juice and the managed environments being provided by SageMaker or AWS or the different kind of environments here. And those managed containers from Hugging Face provide that execution and runtime environment to easily kind of work with the different kind of transformers libraries or packages that you might be working with. So that at a high level is what Hugging Face really is. And like I said, this is not all encompassing. There's so much more that they're always pushing out. They're one of my favorite companies to read up more on and kind of learn as they roll out things. But think of it as a open source kind of ML platform. That GitHub analogy is really key there, where different model providers can bring different models essentially to this kind of platform, and then through the different packages and kind of all these goodies that Hugging Face is exposing, you can do common ML operations that you'll need in a production grade setting. And with that being said, right, just to kind of end the video, if you come to Hugging Face, I'll link all of this down below, right? You will see what I mean. You'll see there's a models tab right here. And this models tab, if you notice, has those different model IDs where for each of these different model providers, right, you can essentially see basically the different models they might have exposed. So for example, if I want to look up llama, you'll see Meta Llama right here is the provider. And then this is the specific model ID that I'm working with. And if I want to use this model, you can see, for example, using the Transformers code, or the code provided by the Transformers API, how can I interface with this? Obviously, this pulls down the model and tokenizer weights, which you do not want to do locally. And that's where you have different cloud providers that you can integrate with. So if you see there's SageMaker right here, that's what I'm familiar with because I'm from AWS, but you can see if your specific provider integrates as well. You can see here there's kind of boilerplate deployment code that pulls down that Hugging Face model IDs, model weights, and then also that managed container that we're working with for inference. So that's where it's very powerful, where all these kind of different model providers for their open source models or open weight models can expose basically that model information here and the model weights here as well. That's what this files and versions are in terms of all the different kind of weights that are exposed here. And then you'll see some of the different packages we've talked about, data sets, right, for different custom use cases. Let's say you have a specific task you want to index on or train on, basically. Let's say it's, for example, Q&A in natural language processing. You can filter and search for the different kind of models that might be available, or sorry, the data sets that might be available that you maybe want to train on. Maybe you have a text to SQL use case that you want to do some sort of supervised fine-tuning on. You can essentially work with that. And I encourage you to kind of explore the docs, see everything that's available. Like I said, I've only talked about a few of the different things here, but via the different Transformers libraries and things of that sort, there's a lot of different packages that are also exposed for common data science kind of operations or techniques. So for example, within training, if you're trying to do some QLORA or PEF-based training, there's a PEF package that helps simplify that process and kind of has a lot of those parameters configured that you can kind of selectively tune. There's different ones for kind of supervised fine-tuning, any reinforcement learning you might be working with, any evaluation. There's basically a lot of different packages that are provided in this same ecosystem that will let you easily interface with these different Transformers models. So that's mainly what I had today. I kind of want to keep it at a shorter video, but if anyone's new to Hugging Face is wondering, what is it? Where do I get started? I hope this was a bit of a useful video in that sense. What I encourage is just take one of the smaller models, maybe like a BERT model, that you can even work with locally or in something like Google Colab. Pull it down, see how you can run inference with it. Maybe see how you can do training with it. That's how I always kind of learn, kind of just trial by fire. And then maybe see as you kind of scale this up for a custom use case, how can I train it on a cloud provider? How can I deploy on a cloud provider? Like I said, I'll have many more videos on each of these topics as well, along with the ones that are already out there. So stay in tune with that Hugging Face playlist, and I'll make sure to kind of provide more context and knowledge around this as well. But yeah, thank you everyone for watching. If you enjoyed the video, feel free to leave a like and subscribe. And if you have any doubts or questions, please just always leave them down below in the comments or reach out to me on LinkedIn, Twitter, wherever it is. I will be back with much more in this space. Thank you.